So previously we looked at adding and subtracting algebraic expressions by collecting the like terms. What I want to have a look at next is what happens when we multiply algebraic expressions. Now you have to remember that 5a is equal to 5 times a. So when we get to something like, if I just give you a simple expression, 5 times a, then that can be simplified by simply taking the times out, which is 5a. If I have 5 times 2 times a, that doesn't become 52a because it's 5 times 2. So 5 times 2 is 10a. If I have more than one pronumeral, so if I have 6 times a times b, a times b, and so it's 6ab. So we simply get rid of the times sign. What happens if I have 6 times a times b times a? Now, remember from our index law, this is a to the 1 and this is a to the 1. So now we have a squared. So I have 6a squared b. One other thing that you may come across is 2 times x times minus 3 times y. Now in this case, this minus 3, we're multiplying by minus 3. So we multiply our numbers first. 2 plus 2 times minus 3 plus times a minus is a minus. 2 times 3 is 6. And we have our pronumerals x and y. It's really easy to get these two areas confused. Multiplying and adding and subtracting. When we multiply, we can just multiply out and get rid of our pronumerals. Now dividing is a little bit different again. So if I have 2 as saying 2 over 2 times 2. And 2 over 2 is 1, so we can cancel those out, and we're left with 1/2. And that's how we can simplify it. Now when we do algebra, it's very similar. If I have 2a over 4, I can do the same. So I know that the common factor here is 2, so I can cancel 2 out of that. So divide 4 by 2, which leaves me with 2, and divide this by 2, which leaves me with 1. So I have 1a over 2, and I can just simply write that as a over 2. If I had a over a, like 2 over 2, a can be divided into a once on top and bottom, so that equals 1. So anywhere where I have the same pronumeral on the top and the bottom, I can cancel them out. So for example, if I have a, b, c on the top and a, x, y on the bottom, where I have a over a, they can cancel to 1, so I'm left with b, c over x, y. I can also cancel if I have a squared over a to the power of 3. Remembering that a squared is a times a, and a to the power of 3 is a times a times a, I can cancel an a on the top and bottom, this a on the top and bottom, which leaves me with 1 on the top and a on the bottom. So what I'm doing, if you're looking here, I'm cancelling 2 a's out of here and I'm cancelling 2 A's out of here. Another example, if I have x to the power of 2y over x y to the power of 3. Here I've got x times x and 1x on the bottom, so I can cancel this x out, and I can cancel one of these x's out. So I'm left with 1x here. And the same with the y's. I've got 3 on the bottom and 1 on the top, so I can cancel this y out and cancel one of these y's out. So I'm left with x to the power of 1 times y, times 1, because this y is cancelled, so I'm left with x on the top, and on the bottom this x was cancelled, so I'm left with y to the power of 2. We can also cancel things if they're in brackets. So if I had x plus 1 over x plus 1, if they're in brackets, that means they're a single term, so I can cancel them top and bottom. It's the same thing divided by itself, so the answer is 1. We'll go into more complex ones of these later, but they have to be exactly the same on the top and the bottom. If you have x plus 2 over x plus 3, this cannot be cancelled down. Okay, this cannot be cancelled down because you can't cancel the x and the x here. So just be careful. You can cancel them when they're multiplied, but you can't cancel them if they're added. Another example might be 2x squared over 4x. I can cancel the 2 and cancel this down to 2. I can cancel this 1x from the bottom and cancel one of the x's from the top, and I'm left with x over 2. Okay, good luck with that.